topic that we have not covered in great detail in class is tidal energy. This module will talk about how it works, its pros and cons, and its current and projected effect on the energy industry. Tidal turbines work in a very similar way to wind turbines. Horizontal turbine generators are placed on the ocean floor, and the current turns the blades. This ends up looking like a wind farm, but underwater. As you can see in this diagram, the generated electricity is transmitted to shore with submarine cables. Tidal energy production relies on the marine currents. Marine currents are inherently predictable, which is really good for grid management. Furthermore, because water is much denser than air, tidal turbines can be much smaller than wind turbines and be placed closer together to result in the same amount of electricity. There are already a couple of commercial tidal energy production projects, many of which are in Europe. However, tidal energy comes with some concerns. Marine life is a large concern when placing tidal turbines in an area. The turbines can kill swimming sea life because the water is moving at very high speeds. There is an increased risk of organisms being pulled near or through the devices. In addition, the EMF and acoustic outputs can affect the organisms, such as those like whales and dolphins, who use echolocation. In addition, tidal energy can contribute to degrading far-field water quality and disrupt sediment processes. On the economic side of things, tidal power is not cheap enough to be directly competitive with fossil fuels. Currently, tidal power is more expensive than other types of energy. For example, it is around 54 to 66 cents per megawatt for the cost of electricity if you're looking at the first tidal stream farms, which is comparable to the cost of wind power in 1980. However, this technology is still quite recent, and more research and development could help bring the price down and make it both more economically viable and environmentally friendly. In terms of future projections, it will take a while for tidal to take off. For example, even in the very idealistic 100% wind, water, solar plan, tidal energy makes up a rather negligible portion of the total renewable energy production amount. So, in conclusion, tidal energy is still a young technology, but with more developed, it could gain ground and become a more prominent source of renewable energy. Thanks so much for listening.